Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's lesson on organic chemistry, we're looking at your question 3s where we test your knowledge of your intermolecular forces, boiling point, vapor pressure, etc., melting points, right? So, question 3, study the vapor pressure versus temperature graphs for 3 organic compounds X, Y, and Z below, which belong to 3 different homologous series. Atmospheric pressure is 100 kilopascal. Write down the vapor pressure of compound Y at 90 degrees. So here, if you look at 5, 10, 15, 20, 25. So each line represents 5. So if you say 80, 85, 90. So somewhere there at 90, we're going to read off the vapor pressure. Then they say that the graphs can be used to determine the boiling points. Define boiling point for 2 marks. Determine the boiling point of compound X. Alright. So there for compound X, atmospheric pressure is 100 kilopascal. So I'm going to come from 100 across and down to determine the boiling point of X. Right? So let's answer the first set of questions before we go to the second set. Right? So write down the vapor pressure of Y at 90 degrees. Right? So there, if I go 70, 75, 80, 85, 90. Go upward 90 there. You can see I draw a blue line and a cross. I basically stop at 150 kilopascal. Right, so the vapor pressure of compound Y is 150 kilopascal at 90 degrees Celsius. Right. 3.2, the graphs can be used to determine the boiling points. Define boiling point. This is the temperature at which vapor pressure equals atmospheric pressure. Right. Right, so determine the boiling point of compound X. Compound X, they said the atmospheric pressure is 100 kilopascal. So I go to 100 kilopascal across, make contact with the graph of X, and I come down. That is at 50, 55 degrees Celsius, right? So temperature at which vapor pressure equals atmospheric pressure, that's boiling point. So boiling point of X, atmospheric pressure 100, boiling point 55 degrees Celsius. Right, so I hope you follow. Let's look at the next set of questions. Right, so 3.3, the homologous series to which the 3 compounds of similar molecular masses belong were identified in random order as alcohol, carboxylic acid, and ketone. Which compound X, Y, or Z is the carboxylic acid for 1 mark? Explain the answer by referring to the type of intermolecular forces and compound of each of the homologous series. And then they say compound X has 3 carbon atoms per molecule. Write down the IUPAC name of compound X. Right, so here we have to compare boiling points and the forces for alcohols, carboxylic acids, and ketones, right, to figure out which one of the 3 is carboxylic acid. Right, so for 3.3.1, compound Z is the carboxylic acid, right, and my reason. And 3.3, they say explain the answer. Right, carboxylic acids have, in addition to London forces and dipole forces, there's a double bond with oxygen, right? So therefore it has 2 sides for hydrogen bonding. Remember, hydrogen bonding is nitrogen, oxygen, or fluorine combined with carbon, right? So there it's a double bond oxygen, therefore it has 2 sides for hydrogen bonding. Alcohols also have London forces, also have dipole forces, but it only has 1 side for hydrogen bonding, meaning in alcohols there's only 1 bond with oxygen. Ketones have London forces and dipole forces between the molecules. So in theory is hydrogen bonding is stronger than London forces and dipole forces. And 2 sides for hydrogen bonding would be stronger than 1 side for hydrogen bonding. So carboxylic acid here has the strongest intermolecular forces, then alcohol second, and then ketone lowest. That in theory means need more energy to break bonds in carboxylic acid. Then alcohol is second, but at least need less energy to break ketones. So if you relate the amount of energy to boiling point, Z there is the highest boiling point, so therefore that must be a carboxylic acid. Y is second, so that's my alcohol, and X there would then be my ketone. Alright? So, intermolecular force in carboxylic acid is the strongest, therefore, highest boiling point. And I assume you remember, boiling point and vapor pressure inversely proportional. Eh? The higher the temperature, the lower the vapor pressure. The lower the temperature, the higher the vapor pressure. So 3.3.3, compound X is 3 carbon atoms per molecule. Write down the IUPAC name of compound X. So if X there is a ketone and it has 3 carbons, which go with prop, then therefore it is propane 2,1. Alright, it's a ketone with 3 carbons. So hope you follow, hope you understand. Wish you nothing but the best. God bless. Bye.